This is Geometry, Chapter 9, Section 2, in which we will be studying translations. And again, we're going to look at it in more detail than we did back in Chapter 4. Now that we understand more about vectors from the last chapter, we can use a vector to translate our image. It's still going to be moving it to a different location. Now this vector tells me two things. It tells me how far to move, the length of the arrow, and it tells me which way to move, pointing in the direction of the arrow. Now I can get away with something on here that you can't. I can use this arrow and show myself where to move these points to. Okay. So that arrow is all three of those arrows are pointing in the same direction and they're the same length. And now I'm just going to connect them. Connect the ends of the arrows. And now if I take the arrows off, you'll be able to see that it's the same triangle, just shifted over. Now, you'll remember from last time when we talked about point P, the new location would be P prime. Okay, this is P prime right here. This would be Q prime. This would be R prime. Just reminding you of the notation in case anyone ever throws it at you. We can do the same thing with this one, just to give you another example. I've got the arrow set up so that I can drag clones of it around. So I'm going to do that. Makes a really messed up looking table. But then I can connect the arrowheads. And then if I erase the arrows again so that you don't have the three-dimensional effect going on, now you have the translated figure. Okay. So the secret is all you have to do is take each of the vertices, each of the corners, and move them in that indicated direction. Now, when you do this on your homework, guys, I'm going to need you to draw the original picture and then draw the translated picture so that I can see that you moved it in the right direction and the right amount. So make sure you do that. Draw the original and draw the final. Okay. If it helps you to leave those arrows on your paper, you can do that. It won't bother me if they're there. You could have a picture that looks like this, and I would be okay with that. Okay, it's up to you. If you want to leave it without arrows, you can do that, or if you want it with arrows, you can do that. Makes no difference to me. Now we can also do this on a coordinate plane. Okay. We're going to use the idea that we learned in the last chapter when we talked about vectors. We have 4 points that they want us to graph. So we'll start by graphing those. -8, -2, here's Q, -9, -5, -4, -7, and -4, -2. So there's our original figure. Nice, perfect lines that are all in the right place. Okay. Now our job is to graph that, and then the image of it, if the translation vector is 7, 1. This is telling us something, remember. This is telling us to go right 7 and up 1 from where we are. So Q goes to Q prime. All I did was add 7 to the x, add 1 to the y. R will go to r prime, add 7 and add 1. S to s prime, t to t prime. Okay. I have 4 points, which is good since I started with 4. -1, -1, -2, -4, 3, -6, and 3, -1. Undo that line. And if I connect those, I should have an identical looking figure. Should be perfectly identical, but I probably don't have the dots all perfectly aligned. Okay. Notice what we did. We did both things they asked for. We graphed the original and we graphed its image. Now, if it helps you to keep things straight by putting Q prime and R prime and all that, go for it. Okay. Make sure you have the original and the final. Okay. Another thing they're going to throw at us is they're going to ask us to describe the translation in function notation and also in words. Okay. And they gave us the points for A and B. What they're asking us, guys, is how do you get from A down to B? In this case, down. Okay. What do we have to do? We have to go 1, 2, 3, 4 to the left, and 1, 2, 3, 4, 5, 6 down. Okay. That's how you would describe it in words. Left 4, down 6. If you're in the direction mindset, you could say west 4, south 6. I would understand that as well. Now, how do we write this in function notation? XY, and I left my arrow out, doggone it. XY goes to x minus 4, y minus 6. Okay. Function notation is not really that hard to do once you have the words. It's a piece of cake. Alright. Now they're also going to ask us to do the same kind of thing. How do we get from A to C? And we have the coordinates here. Well, to get from A to C, we have to take the C values minus the A values, like we did in last chapter. So 7 minus 1, and then 1 minus 4, gives us a vector of 6, -3. Okay. Translation's pretty straightforward. Not a lot of heavy lifting in this one. If you had questions along the way, hopefully you wrote those down, bring them in to ask, and we'll see you in class.